In today's video, we're going to be covering how to use the rational root theorem. Okay, so with the rational root theorem, you are looking for the rational roots of a polynomial standard form. And the reason looking for is emphasized here is because the first letter of each word is LF, and that's the statement of the rational root theorem. It's the factors of the last slash constant coefficient divided by the factors of first coefficient. And obviously that can be easy to forget, so that's why I like to say you're looking for, so you remember that easily. Okay, so let's apply that right away. What are the possible rational roots of x to the fifth plus x to the fourth plus x to the 3 plus x squared plus x plus 1? Okay, so since this polynomial is already in standard form, we don't have to do anything, so we can go straight into it. So we have the formulas plus or minus last over first, remember, looking for. So what are the factors of 1? Well, the only factor of 1 is 1, so let's write that. And what are the factors of the first coefficient? Well, this is secretly 1 x to the fifth in disguise. So it's going to be just 1 again. And don't forget the plus or minus. So our possible rational roots are going to be 1 and negative 1. Because this is just 1 over 1 is 1, and it's going to be plus 1 and minus 1. Okay, next problem. What are the possible rational roots of 5x to the 8th plus 7x to the 9th plus 4? Okay, in this problem, this is not in standard form because the exponents are not decreasing. So let's write it in standard form. 7x to the 9th plus 5x to the 8th plus 4. Okay, let's write the factors of the last coefficient, which is the constant. And if there is no constant, then it's just 0. Okay, so the factors of 4 are going to be 4, 2, 1 divided by the factors of the first coefficient, which is 7. The factors of 7 are 7 and 1. Okay, plus or minus. And since we have commas here, multiple numbers, we're going to have to try every possible combination. And to do that, we're going to do this little system. So for 4, we're going to do 4 divided by 7, and then 4 divided by 1. For 2, we're going to do 2 divided by 7, then 2 divided by 1. For 1, we're going to do 1 divided by 7, and 1 divided by 1. Okay. So we're going to have plus or minus 4 over 7 plus or minus 4 over 1, which is just 4. Okay, now moving on to 2, since we covered the cases for 4, we're going to have plus or minus 2 over 7 plus or minus 2 over 1, which is 2. Okay, since we're done with the cases for 2, we can move on to 1. And we're left with plus or minus 1 over 7, and then plus or minus 1 over 1. Plus or minus 1 over 1, which is 1. And these are our possible roots that are rational for this polynomial. Okay. And as a last note, let's just say that the rational root theorem does not find every possible root. It only finds the rational ones. So let's say we have the quadratic x squared is equal to 2. Okay? We know that we can just take the square root of both sides, and we're left with x is equal to plus or minus the square root of 2. Okay. Let's try this again, but with the rational root theorem. We have x squared, in standard form, x squared minus 2 is equal to 0. Okay, we're going to do our usual last over first. So factors of 2, 2, comma, 1, plus or minus, divided by the factors of the first one, which is 1. But here the problem is we have plus or minus 2 and plus or minus 1. Neither of these match up, and that's because the square root of 2 is not a rational root. So it will never be found by the rational root theorem.